Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing cubics in general form. That is, we're going to graph cubics whose equation is written like this. So what we really need to do is find the intercepts, the y and x intercepts, and then we need to look at its behavior. If a is greater than 0, it's top right, bottom left, and a is less than 0, it's top left, bottom right, just as it was when we looked at transformations of cubics. But I just wanted to make a note on the nature of roots. So if x minus a is a factor, then there is a single root at a, the x-intercept will kind of be cut. Whereas if there is a double root, that means x minus a squared is a factor, kind of bounces off the x-axis. And if there is a triple root, then we have a stationary inflection point there. So this last case only occurs when we're looking at transformations of cubics, when they can be written as y equals a, x plus h cubed plus k. So let's look at an example. We're going to graph this function here. So first we're going to calculate its intercepts. So the y-intercept is really easy to find. It is just the y value when x equals 0. So if it's written in this form, it's just going to be d. It's just going to be the constant term. So the y-intercept is 2. We'll plot that there. Now we're going to find the x-intercept. So to do that requires a bit of work. We have to let y equal 0. So because each of the terms have a common factor of 2, I'll write out this 2 at the front, and I'm left with x cubed minus x squared minus x plus 1. So what I want to do is I want to factorize this cubic to reveal the solutions. So we might be able to see very clearly here that 1 is a root of this polynomial here, because the coefficients add to 0. 1 minus 1 minus 1 plus 1 is 0. So what that means is that x minus 1 is a factor, 1 is a root. We will use synthetic division. So I'll put the root there, and the coefficients of the cubic are these. So we always bring down this first number, then we multiply it by the root. 1 times 1 is 1, that goes here. So then we go 1 times 0. We always multiply a number down here by the root. That is, of course, 0. That goes up here. We add to find the remainder. Whenever we get a number down here, we multiply by the root. So 1 times negative 1 gives us negative 1. And the remainder for the whole division is 0. So we've just calculated that we can write this cubic here as x minus 1, we already knew we had that factor, times x squared minus 1. Remember, these are the coefficients of the quadratic, so it's 1x squared, 0x minus 1. So we can factorize this further. This is just the difference of two squares, so it's x minus 1 times x plus 1. So we've actually factorized this cubic, and we see it can be written as x minus 1 squared times x plus 1. We have a double root at x equals 1. So it's going to come down and bounce off the axis. Now, x equals minus 1 is a single root from here. So it's just going to come up, cut, then it's going to stop and turn around at some point. We're not actually calculating the turning points here. That'll come later. So it comes up through here, stops and turns around, goes through the y-intercept, and then it will turn around and bounce off the axis. So for now, just estimate turning points, get the intercepts right, and then we're done. Let's look at an example now in which we find the equation. So we have a cubic graph that has x-intercepts here, also passes through this point. We're going to calculate its equation. So the equation is going to look like some number times x subtract the first intercept, so x subtract negative 2 is x plus 2, times x minus the next intercept, well, x minus 0 is just x, and then multiply by x minus the third intercept. So let's just make this a bit easier to work with. This is going to be ax. Now x plus 2 times x minus 2 gives us x squared minus 4. So how are we going to find the value of a? We do that by substituting a point other than the x-intercepts. So we will substitute y for -6 and x for 1. So we just get a times 1 multiplied by 1 squared minus 4. So we get -6 equals a times -3, and that of course gives us a equals 2. So therefore the equation is going to be, I'm just going to substitute a for 2 here, it's going to be 2x multiplied by x squared minus 4. You may be asked to give it in expanded form, in which case we can easily expand this 2x times x squared and 2x times -4. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.